So now let's discuss very first electronic effect that is known as inductive effect. Inductive effect. So what is the inductive effect? So inductive effect, actually it is the polarity developed in carbon chain due to shifting of sigma bond electron as a result of electronegativity difference is known as inductive effect. So polarity developed in carbon chain due to shifting of sigma electron. Let's say we have a carbon chain. I am not writing all the valency of carbon, it is understood. And we have any external element and X, let's say, not external element, a non-carbon element, let's say. Okay, it could be carbon element, we're gonna see it further later on. So X must be having a different electronegativity than carbon. Electronegativity of carbon is not equals to electronegativity of X. So it might be pulling the electron or it might be pushing the electron. Why I'm pulling and pushing? Because that bond is actually a sigma bond and it is a covalent bond, means it has two electrons over here. And these two electrons are keep on moving inside their space such like that it's look like an electron cloud. Most of students have a question, while we have only two electrons, then why it is electron cloud? It is not it is cloud. When you see it, these two electrons are moving such a fast way in that particular space that it is looking that it is a cloud. Now when electrons are moving in such a fast space, and it is known as a cloud, but let's say electronegativity of X, let's say is greater than electronegativity of carbon, means X has a greater tendency to pull the electron as compared to the carbon. Now carbon X and carbon, now the electron cloud will shift towards the X more. So it has not completely shifted of electron, it is partially shifting of electron. So it will get delta negative and it will get delta positive. And this slightly shifting here also can double delta positive and triple delta positive. Means this a little bit effect is shown on this carbon also, because it is this bond also is influenced under the electronegativity of that X. It has such a pulling power that it influences up to 3 to 4 carbon. After 4 carbon, this effect is not seen in the single sigma bond. So this is known as inductive effect. Polarity developed in carbon chain due to shifting of pi bond electron as a result of electronegativity difference is known as inductive effect. And this effect was discovered by scientist which was named Ingold. Ingold was the name of the scientist which discovered this effect. So you have to remember that the scientist was Ingold. Now what is it is effective up to 3 to 4 carbon only. After once it becomes neutralized, means it doesn't have any effect. So magnitude of I effect is inversely proportional to distance. Magnitude of I effect is inversely proportional to the distance, right? So more the distance from the carbon, lesser will be the inductive effect, and it is a, as we have written, it is a permanent effect. Permanent effect. And the reference element is hydrogen. Means electronegativity is greater than hydrogen, then it is showing the plus I effect, and electronegativity is less than hydrogen is known as let's say electronegativity is greater than carbon. Reference hydrogen we will say, but electronegativity greater than electronegativity of X, carbon is greater, then it will be pushing the electron. It will be known as plus I effect, and electronegativity of carbon is less than electronegativity of X, then it will be minus I effect. So in some group of atom has greater tendency to attract shared electron of covalent bond. So means we are journalized. It is a journalized. But as the definition we see has a greater tendency to pull electron from carbon chain are known as negative I group, and has a greater tendency to push electron from carbon chain has a positive I group. So these are the negative I group and these are the positive I group. So let's understand first of all what are the negative I group. So let's write a heading, negative I groups. So negative I group or negative I effect. Let's say carbon, 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 and electronegativity of X is greater than electronegativity of carbon. So it will eventually pull electron delta negative, delta positive, double delta positive, triple delta positive. We know the magnitude of delta positive equals to delta negative positive, double delta positive, and triple delta positive. And we assume that after 4 electron it disappears, or we assume that on 4 electron it is very minimum, but it is not after the 4 electron. So if we talk about, yes, someone is pulling electron from the carbon chain, but there are lots of element or lots of group which pull electron from the carbon chain. So how do we compare which is pulling more and which is pushing more? Which is pulling more or which is pulling less? Right now we are discussing about the negative I effect, so we are talking about the pulling effect only, or we can say it is an electron withdrawing effect. Electron withdrawing effect. This effect is known as electron withdrawing effect. So let's solve some examples, and then you will be better able to understand which have the more minus I effect and which have more plus I effect. So first of all, let's say fluorine, chlorine, bromine, iodine, OH, SH, NH2, PH2, NH3 plus, NH2, OH2 plus, OH, NO2 plus, NO, FOH, NH2, SH, Cl, C triple bond N, CH double bond NH, CH2, NH2, COH, COCl, S double bond O, OH, S double bond O, OH, NF3 plus, NH3 plus, CF3, CCl3, CBr3, CI3. So majorly let's discuss. I'll appreciate you pause the video and try to answer by your own, and then we're gonna discuss it. So now let's discuss it. What is the order of minus I effect? So fluorine, chlorine, bromine, iodine. We know that this valency. I hope you know that it is a group which is attached to the carbon chain, right? This valency means this is the group which is attached to the carbon chain. Now it is pulling electron. All these are minus I group, but which has more tendency to pull the more electron, like minus I, which has more tendency, like fluorine, chlorine, bromine, and iodine. We know fluorine has a greater tendency to pull the electron because electronegativity of fluorine is more. Then chlorine, then bromine, then iodine. So due to electronegativity, obviously fluorine has more tendency than chlorine. Down the group, electronegativity decreases. So in halogen, down the group, the electronegativity is decreasing. Then OH and SH. We know down the group electronegativity decreases. So the group that is directly attached to the carbon chain has more electronegativity as compared to the other. So it will be more. NH2 and pH2, obviously electronegativity factor. NH3 plus NH2. Now these both are equally electronegative, but it is a neutral element and it is a positively charged element. We know that the positive charge have more tendency to pull the electron as compared to a neutral element if the element are same. If they are not same but still positive charge have a very greater tendency to pull the electron because it is electron deficient. A lot of electron deficient as compared to electronegative more electronegative element, you can say. So positive charge has a lot of tendency to pull the electron. So yes, whenever there is a positive charge element directly attached to the main carbon chain, right, then we have neutral element and we have negatively charged element. Always the positive charge element has more minus I as compared to remaining other, or first of all a positive charge and more minus I than neutral than negatively. So when we have A positive which has more tendency than A neutral, then A negative, this is the minus I order, right? OH2 plus OH again positive charge. Then we have the sixth problem example, NO2 and NO. Now this element is same. We gonna check by one and one element, right? Whole group we can check, or we can check by going to first element then checking other element. Now here it is oxygen extra. So oxygen is a more electronegative, right? So NO2 will be more electronegative. Why? Because the oxygen is here extra, which is adding minus I effect more to the group FOH NH2. So according to the electronegativity of the element directly connected to the carbon chain, SH and Cl. So if we compare from SH and Cl, now we know that chlorine has more electronegativity. You can see the periodic table. Cn, CH2, CH2, NH2. This is sp hybridized carbon, so it has more electronegativity. Percentage of S character is more. Why percentage of S character is more than electronegativity more? Because percentage S character increases closer to nucleus. It is closer to the nucleus, so it has more electronegativity. Closer to the nucleus means closer to the positive charge, which is nucleus, which has proton. So more is the electronegativity. So sp, then it is sp2, then it is sp3. COH and CO, the reference is hydrogen and chlorine. So it is more electron. SO2H, SO3H and SO2Cl. Here it is double oxygen extra added. So here it is the electronegativity is more. Now NF3, NH3. Now N is same, positive charge on both of the nitrogen. Here it is fluorine, here we have hydrogen. So fluorine is more electronegative. CF3, CCl3, CBr3. Obviously, what we see? A, B, C. Let's say this type of compound we have E, F. So first we check A. A is same. Then we check E and F is same. Then B, then C. What I mean to say? Then first we check carbon. Carbon is same all. Then we check fluorine. Fluorine is different. And chlorine, bromine, iodine. So more the minus I effect, more the electronegativity, more will be the negative I effect. Now there are good questions. That's why I have mentioned them separately. These are two examples are quite important. These two examples are quite important. You need to understand that. Then I have two examples, right? You need to listen that carefully. I have two examples. One is N R R R3 plus, and one is N H. This is NR3 plus and this is NH3 plus. Now, first of all, I'll again advise you to pause the video and try to answer by your own. So now let's talk about it. NR3 plus and NH3 plus. Now NR3 plus, you can say that what you should say. We know H and R. Between H and R has a tendency to push electron and H has a neutral tendency. And it has tendency to push electron, right? So it is actually pushing the electron. I am just asking you the comparison of negative ion in between them, which has more negative ion and which has less negative ion. So it will push electron. It will also push the electron. Now it will push electron, but with let's say not pushing the electron. Let's say okay. Now what is happening? The three groups are pushing the electron. Then the intensity of positive charge should decrease if there is a positive charge and you are adding electron over it. So you are decreasing the intensity. So when we have less intense positive charge and we have more intense positive charge, so which can pull better amount of electron, or which has better tendency to pull the electron from the carbon chain, which has more positive charge intensity. So you will be answering like this, but this is the incorrect answer. Now why it is incorrect, let me tell you. In organic chemistry, first we have experimental things, then we explain it with some explanation. We give it some explanation later by looking at theory. So you can't, these are some irregularities from the normal order, from the normal conception, which are explained with the help of some other concepts. It is not like in organic, which are some exceptions. We can say these are some irregularities from the general concept, which has been explained by some other methods, right? Now, what is that other method? So, first of all, you should answer by this. Then it should have more plus sign. Now, what is the correct answer? What could be the correct answer? What is the correct answer and correct explanation? So, correct explanation is, let me ask you a question, that we have CH3, CH2, CH3. We have CH double bond CH2, and we have C triple bond CH. This is sp3 hybridized, this is sp2 hybridized, and this is sp hybridized. So actually this is more minus I, this is lesser minus I. Here percentage S character and bond angle. Percentage S character is 25%. Here it is 33.33%. And here it is 50%. So this is the order of electronegativity, right? If I write the order of electron, and bond angle here is 109 degree 28 minute. Here bond angle is 120 degree, and here bond angle is 180 degree, right? So what you are observing here, more the bond angle in the hybridized element, more is the electronegativity. More is the bond angle, more is the electronegativity. Now how it is related with that question? We have NR3 plus and we have NH3 plus. So these are all bulky group. These are pushing to each other, and these are relatively less bulky or very less bulky, and they are not pushing. So when they are pushing, the bond angle increases. So bond angle increases means electronegativity increases. So this becomes more electronegative as compared to NS3. So between NR3 plus and NS3 plus, NR3 plus is more electronegative due to the more the bond angle. Now, correct? Again I am explaining NR3 because R bulky group as compared to HO, they are pushing each other, and the ideal bond angle should be 109 degree 28 minute. But due to that pushing effect, the bond angle is becoming more. Bond angle is becoming more. So bond angle more, so electronegativity is more, as we have seen in the previous example. So there is one more question between OR and OH. Again, R is a bulky group. These two are lone pair. So R is a bulky group. R will try to increase that bond angle as compared to H. If you use that plus I formula, you again see that OH will be more minus I. But due to bond angle is more, so it has bond angle is more, so it has more minus I. So OR is greater than OH, because here due to repulsion of oxygen from that carbon oxygen bond, the bond angle is more, so more is the minus sign. So we have seen nearly a lot of examples of negative ion. But what should be the order, the overall order of negative ion? What should be the overall order of negative ion? So you have to remember a series. You have to try to remember a series. But still, we cannot include each and every element. It is impossible to include each and every group element and all ions in this series, but most widely used we are using here. Remaining you can identify by your own that why it is more minus I plus I. So first of all, in our series minus I series, the very first element is NF3 plus, then NR3 plus, then NH3 plus, then NO2, then cyanide, then SO3H, then acid, then fluorine, then chlorine, then bromine, then iodine, C double bond OR, OH, C triple bond CH, phenyl ring, CH double bond CH2, then H. Now how you will be remembering the series? I am just marking some of the portion which we have already studied. Like we will study NR3 and NH3 comparison right now. How NR3 is greater than NH3. And we have seen NF3 should be is positive charge and fluorine is the most electronegative element. Then after positive charge it is coming the NO2. The nitrogen and oxygen, but with a neutral element. So all the positive charge are coming prior. Then fluorine, chlorine, bromine, iodine we have already seen this series. OH we have already seen. Right. A little bit you have to remember, like cyanide has more than SO3H than acid. Obviously between acid and ester, the acid is more because ester will have R will have plus I, which will reducing overall withdrawing effect. Now let's talk about this. Now let's talk about these groups. Now let's talk about these groups. Now if we talk about these groups, one is acetylene, phenyl and ethene. So when we compare between them, obviously we know this is sp hepatitis, which is more than CH double bond C. Right. So this is more. Now between two of them, between these group and these group, both are same. But here we have hydrogen, and here we have this remaining group. So let's say this is minus I and this is also minus I. Let's say these two are same, but the remaining group should add minus I or plus I too, and hence the overall effect. So it is adding minus I because it is sp2 hybridized, and it is adding zero effect. So overall minus I is phenyl. Let's understand again. I'm telling you a very good example. Like this, let's say we have some scale to measure the minus I. I'm mentioning that is an arbitrary data just to explain the concept. Let's say this ethene group has minus 25 unit of minus I effect. Now remaining this portion also a minus I group because it is sp2 hybrid. Let's say it is minus 15 group and it is 0 group hydrogen. So overall effect is minus 25 and overall effect is minus 40. So that's why it is more minus I. So that was all about minus I. Now let's try to explain how do we have the plus I effect. The plus I effect. Again explaining, there might be some groups and elements are missing, but majority you have to remember this. Remaining you can identify your own like NH2 and a lot of groups. Like obviously here we'll be having NH2, where after that we will be having NH2. So there are a lot of groups which you can place by your own. And sub data you have to remember, like you can compare between cyanide and SO3H, right? And that has to be remembered, and when it was calculated experimentally. But there are some comparison which you can do, and which we have seen already. So let's talk about plus I effect. Plus I effect or plus I groups. So plus I groups are those groups which has more tendency to push the electron. It is called electron pushing groups, or this effect is known as electron donating effect. This effect are known as electron donating effect. It has delta positive, it has delta negative, double delta negative. So delta positive should be equals to R delta negative plus double delta negative plus triple delta negative. The modulus of these should be same. Now what are the plus I groups? Obviously when there is a negatively charged group. So what to show plus I group? All alkyl group and all anionic, which has anion and which has alkyl, show plus I effect, right? Now in alkyl group, plus I effect is directly proportional to the size of alkyl group. Let's say in alkyl group we have methyl, ethyl, propyl, butyl. So more the size, more will be the plus I effect. Now let's say, and in isomeric alkyl plus I effect number of branches. Let's say CH2 or CH2, CH2 or CH3. Now when the number of carbon are same, then it is directly proportional to number of branches. So it has more number of branches, less and less. So it is more plus I. So these are the general explanations, general criteria to explain the plus I. Now if we try to generalized order of plus I, try to write the generalized order of plus I group. So you can write it as CH2 negative, then NH negative, then O negative, then C double bond O negative. Right. These are the negatively comparison between negatively charged. When we have an ionic group, in an ionic group, the more the minus, first of all anion should directly connect with the carbon chain. In the carbon chain it should be directly connected. Now when it is directly connected to the carbon chain, so more the electronegative, let's say carbon is more, it has more tendency to hold the negative charge. Oxygen is less electronegative, sorry, carbon is less electronegative, oxygen is less, more electronegative, so it has more tendency to hold the charge. So when it holds the charge with maximum capacity, there is less tendency to repel the electron. Less tendency to repel the electron pair, a sigma electron pair, right? So it has a less minus sign. So in an ionic group, more the electronegativity, less will be the minus sign. Now in that the carbon, the oxide is not directly connected with the carbon chain, so it has lesser minus sign. So these are the comparison. Now there is one more comparison it could be asked, like we have CH3, CD3 and CT3. We know hydrogen, deuterium and tritium. Hydrogen, deuterium and tritium. All these are isotopes. All these are isotopes, right? So when these all are isotopes, so how can you say which are more plus I, which are more minus I? So you know that when we have these three groups, the due to a heavy nucleus, the let's say CH, H, and let's say we have bond length 1H1. Now we have C some bond, and let's say we have deuterium. Now due to the more vibration of deuterium, heavy size and more vibration of deuterium nucleus, the bond length changes. So the bond length order is CH. The bond length order is the heavy nucleus, more vibration. Let me take. Let's understand it further. Not due to the more vibration, due to the heavy nucleus. Due to the heavy nucleus, it has more tendency to attract the electron. So bond length becomes less. Let me explain again. It has one. What is the difference? One neutron, two neutron, and three neutron. So neutron is more. So heavier the nucleus. Heavier the nucleus. Here we have hydrogen nucleus. One proton. We do one proton, one neutron. Tritium means size will become more. One proton, two neutron. Hydrogen, deuterium, and tritium. So due to the heavy nucleus, it has a greater size of positive charge, right? So electron or size is become more. The atomic size is become more. So it will be pushing the electron with more tendency. Stop thinking about vibration. This is the it is have more tendency to push the electron because size is more. So CD3 which CT3 which will have more plus I than CD3 than CS3. So this was the overall order of positive I and negative I, the generalized order in inductive effect.